Okay, so you want to build an AI that can actually, get things done in the real world.
Yeah.
Like actually plan a sequence of actions to achieve some kind of complex goal.
Right.
We're talking robots, logistics, all that jazz.
Exactly.
Well, today we're diving into a paper that grapples with a pretty fundamental question in automated planning.
Okay.
It's called The Value of Goal Commitment in Planning.
Interesting.
And the core idea is, can we make these AI planners smarter?
Okay.
By explicitly telling them, hey, once you've achieved a certain goal, just stick with it, at least for a bit.
Ah, I see. So like trying to give them a bit more strategic thinking.
Exactly.
Instead of just blindly exploring every possible action.
Right.
So they introduced these things called commit actions.
Yeah.
And they've tested it out using, one of those state-of-the-art planners.
They use that, what is it?
LAMA.
LAMA,
Yeah.
right?
Yeah.
And, we've got the results, and we're going to break it all down.
I'm really curious to see what they found because, this idea of goal commitment, it goes way back to the early days of planning.
Yeah, it's like a classic concept getting a fresh look.
Right, exactly.
So, for anyone who might be a little fuzzy on the basics here,
Sure.
when we talk about automated planning, what exactly are we talking about in the context of machine learning?
Yeah, so at its heart, automated planning is all about teaching an AI to figure out
Okay.
a sequence of actions that can transform some initial state of the world into a state where, it's achieved its goals.
So, it has some kind of objective in mind.
Yeah, exactly.
And it needs to find the right steps to get there.
Right.
Okay.
A simple example, like think about a self-driving car.
Okay, yeah.
It needs to get you from point A to point B.
Right.
So the planning system, it has to figure out all those little actions.
Like the turns and the lane changes and all that.
Exactly. All the turns, the lane changes, when to accelerate, when to decelerate to get you to your destination.
Safely and efficiently.
Yeah. Ideally, both safely and efficiently.
Okay.
And this paper, they touch on some of the historical approaches to this problem.
Yeah.
Like back in the day, you had these two main camps.
Good.
You had the partial order planners, which were all about flexibility.
Okay.
They didn't really care too much about the specific order of actions. And then you had the total order planners.
Okay.
Which they were all about deciding on a very specific sequence of steps early on.
So more rigid?
Yeah, you could say that.
Okay.
And often this ordering was based on like a predetermined order of goals.
So they were like, we need to achieve goal A, then goal B, then goal C kind of thing.
Precisely.
Okay.
But then came the rise of these heuristic search planners.
Yeah, these are like the more modern ones, right?
Exactly.
The ones that are really good at estimating how close they are to the goal.
Yeah, they evaluate the current state of the world and use heuristics to guide their search. And with these, this explicit commitment to a goal order, it kind of fell by the wayside.
So this paper is like bringing that idea back.
Exactly. They're revisiting goal commitment in light of these modern techniques.
Okay, so let's dive into how they actually do that with these commit actions.
Yeah.
It sounds like they're basically saying, hey, planner, if you've achieved something, try to stick with it.
Yeah, that's a good way to put it.
Like, don't just go undoing things unnecessarily.
Yeah, like imagine our self-driving car again.
Okay.
Let's say the sub-goal is to be in the correct lane for an upcoming turn.
Right.
So once the car's in that lane, a commit action would essentially prevent the planner from even considering any actions that would take it out of that lane.
I see. So it's like locking in that progress.
Exactly, at least within that specific attempt to find a route.
Okay, so it's not like it's completely stuck.
No, it's more like a focused exploration.
Okay.
It's enforcing a certain order of achieving goals within a particular part of the problem-solving process.
But, okay, here's the thing that immediately pops into my head.
Yeah.
What if committing to something too early turns out to be like a bad decision later?
Oh, yeah, that's the big question.
Like, could the planner get stuck in a dead end?
Right, and the paper acknowledges this trade-off.
Okay.
So, making the right commitment, it can really streamline the search.
Yeah, it makes sense.
And you can find good solutions much faster.
Right.
But if you commit to the wrong thing, you can end up in these dead ends where the best move would actually be to undo that committed goal.
But you can't because you've committed to it.
Right, exactly. At least not in that specific branch of the search.
Okay.
But, and this is important, the algorithm isn't totally rigid.
Okay.
It can still explore other possibilities where that goal isn't, persistently maintained.
Okay, so it's like exploring different branches.
Right,
With
exactly.
different commitments.
Precisely.
Okay, now I noticed they use this whole strips planning task framework.
Yeah, it's a pretty standard way to formally define these planning problems.
Okay, so for our listeners who might be familiar with that, could you give a quick rundown of what that involves?
Yeah, so a strips task, it basically has a few key components.
Okay.
First, you've got your fluents, which are like the variables in the world,
Okay.
things that can be true or false. Then you've got your actions,
Okay.
and each action has preconditions.
Which are like the things that have to be true.
Yeah, before you can take that action.
Okay.
And then each action also has effects.
Which are the things that change after you take the action.
Exactly. So it's like, if these things are true, then I can do this, and this will be the outcome.
Okay, makes sense.
Then you've got your initial state, which describes what's true at the very beginning.
Like the starting point.
Right.
Okay.
And finally, you've got your goal specification.
Which is what you're trying to achieve.
Which is what you're trying to achieve.
Exactly. It describes what needs to be true for the problem to be considered solved. Okay, so that's the basic setup. And then they layer in these commit actions on top of that.
Right. So they focus on the goals that aren't true initially.
Okay.
But that can be made true by taking some action.
Okay.
And for each of these goals, they introduce a corresponding commit proposition.
And this is like a flag that says, we're committed to this goal.
Precisely.
Okay.
And these commit propositions are what the new commit actions manipulate.
So they categorize the original actions based on how they interact with these committable goals.
Exactly.
Okay, so walk me through those categories.
Yeah. Okay, so the first category is actions that add goals that we can commit to. And for each of these actions, they create new commit versions of that action.
Okay.
And these commit actions, they not only have the original effect.
Like actually achieving the goal?
Yeah, but they also add this commit proposition.
To mark it as committed.
Exactly.
Okay, so what about actions that could potentially undo these committed goals?
Right, so that's the second category.
Yeah.
These are actions that delete goals that we've, potentially committed to. And for these, they create what they call force commit actions. And these are similar to the original actions, but they have this extra precondition.
Okay.
They can only be applied if the corresponding commit proposition is not true.
So it's like a safeguard.
Yeah, it prevents you from undoing something you've committed to.
Okay, and then what about actions that don't directly affect these committable goals?
Yeah, so those are the third category.
Okay.
And those actions, they just stay the same.
They're unchanged.
Right.
So you've got this whole new set of actions now, and you've got these commit propositions.
Yeah.
So how does the overall goal that the planner is trying to achieve, how does that change in this new commit planning task?
So the goal now includes achieving all the original goals that weren't part of this committable set.
Okay.
And for the goals that were committable, the new goal is to achieve their commit versions.
So it's not enough to just achieve the goal. You have to explicitly commit to it.
Exactly.
Okay, and then they have some theoretical results about this whole transformation process, right?
Yeah, they prove that the original planning task and this new commit planning task are essentially equivalent.
In terms of whether a solution exists.
Exactly.
So it's not like this transformation fundamentally changes the problem.
Right. It's more like a reformulation.
Okay, but theory is one thing.
Yeah.
What happens when you actually put this into practice?
So they ran a bunch of experiments using a ton of different planning problems.
And they used LAMA.
Yeah, LAMA, it's a really powerful state-of-the-art planner.
Okay, so what did they find?
Well, the results were kind of a mixed bag.
Okay.
When they looked at the overall performance across all the problem, LAMA actually did slightly better on the original tasks.
Oh, interesting.
But when they looked at specific planning domains,
Okay.
there were some domains where the commit planning task clearly outperformed the original.
So it wasn't a universal win.
Right, it was very domain dependent.
Okay, so in some cases, committing to goals helped, and in other cases, it didn't.
Yeah, pretty much.
What about the quality of the solutions?
So they found that in many domains, the commit planning task actually led to higher quality solutions.
Even if it didn't always solve more problems.
Right. So when it did find a solution, it was often a better solution.
Interesting. And what about the speed?
That also varied a lot depending on the domain.
Okay.
Sometimes the commit planning task led to faster solutions. Sometimes it was slower.
So it sounds like the key takeaway is that the success of this approach really depends on whether the planner can identify the right goals to commit to.
Absolutely.
If it makes the right commitments, it can be really beneficial.
Right.
But if it makes the wrong commitments, it can backfire.
Exactly.
And this kind of ties back to that historical debate, right?
Yeah, between those early planners.
The ones that favored least commitment versus the ones that were all about early commitment. And then, the heuristic search planners came along and kind of sidestepped that whole debate.
Yeah, they were more about evaluating states and using heuristics.
So this paper is like a fresh look at that old debate.
Yeah, it's trying to bring back the idea of goal commitment.
But in a more modern context.
Right, with these sophisticated heuristic search planners.
Okay, so to summarize the key contributions here.
Sure.
This paper introduces a new way to explicitly incorporate goal commitment into planning problems. And they do this by adding these commit actions and commit propositions.
Right.
And the idea is to guide the search by making the planner stick with certain achieved goals.
At least in parts of the search space.
Exactly.
And their experiments show that this can be really beneficial.
In certain domains.
Yeah, and especially when the planner can accurately predict which goals to commit to.
Right, because if it makes the wrong commitments, it can actually hurt performance.
Yeah, it's all about making those smart decisions.
Okay, now for the fun part, novel notions time.
Okay, I like where this is going.
Let's brainstorm some future research directions based on this paper.
Yeah, let's get creative.
So one thing that jumps out at me is this whole idea of adaptive goal commitment.
Interesting.
Instead of just statically compiling the problem with these commit actions, what if the planner could dynamically decide which goals to commit to during the search?
Yeah, that would be much more flexible.
Right, and maybe we could even use machine learning to guide those decisions.
Oh, that's a cool idea.
Like train a model to predict which commitments are likely to be beneficial.
So the planner could learn from its experience
Exactly.
and make more informed commitment decisions over time.
Right, and maybe even learn to strategically uncommit from goals if necessary.
Yeah, that would be a huge step forward.
Okay, what else?
Well, another idea that I've been thinking about is applying this framework to hierarchical planning.
Hierarchical planning, okay?
So imagine a planner that can commit to goals at different levels of abstraction.
Okay, like high-level goals and then more concrete sub-goals.
Exactly.
Interesting.
So a high-level planner could commit to a certain overall strategy, and then the lower-level planners would have to work within those constraints.
So it's like a top-down approach to commitment.
Right, and this could be really useful for complex problems with lots of interacting parts.
Yeah, like those real-world scenarios we talked about earlier.
Right, like logistics or robotics.
Where you have all these different components and subtasks.
Exactly.
Okay, those are some really cool ideas.
Thanks.
And, these are just our initial thoughts.
Yeah, we're just scratching the surface here.
So to all our listeners out there, we highly encourage you to check out the full paper.
Yeah, the link is in the show notes.
And really dig into the details.
There's a lot more to explore there.
All right, so to wrap things up.
Okay.
This paper gives us a really interesting new approach to incorporating goal commitment into AI planning. And while the results weren't universally positive, it definitely highlights the potential benefits of this approach.
And it opens up some exciting avenues for future research.
So as you go about your day, think about this.
Okay.
How might explicitly modeling goal commitment, maybe in these adaptive or hierarchical ways, how might that change the way we build and use AI agents in the real world?
It's a big question, but it's worth pondering.
Absolutely. All right, that's it for this deep dive into the value of goal commitment and planning.
Thanks for having me.
Thanks for joining us.